Hello, fifth graders.
Welcome back to your TV classroom.
Back. We're going to have a great day. We'll see how far we get.
Yeah.
I'm loving this because we're just learning so much. It's really exciting.
Yes.
I loved our lesson last time. I'm hoping you got to have conversations as a class or with your peers about the things we learned about salmon.
Mm-hmm.
Before we get going on our lesson today, let's check in with our zones.
Zones coming right up.
Here they come. How are you feeling today? It's the same day for us, but sometimes we feel different in a day.
Mm-hmm.
How are you feeling, Miss Oslin?
Excuse me, I'm mostly in the green zone. I'm starting to get hungry.
I was going to say the same thing.
So would that be like the blue is hungry in the blue zone?
Yeah, where you kind of get tired
moving
and
slowly, not quite thinking straight.
Yep. We had to
Low
really
energy.
rehearse what we were going to do
We
before
did.
this lesson because it's complicated.
Mm-hmm. How are you?
Kind of blue.
Yeah,
I was green.
you were.
I bet after lunch I won't be blue anymore. I need some food.
We need some energy.
We do need some energy. We need to transfer some energy from the food to our bodies.
Yes, we do.
Mr. Kevin, how are you today?
You know, that's a great scientific thing to ponder is our bodies will sometimes be blue and all we need to do is fuel them.
Mm-hmm.
And then they go
Right.
green again.
So, yeah.
It's true.
But you know what I'm going to do?
What?
Have
Just
some
for
kind
you
of magic.
teachers, I've got this magic wand
Ooh.
Mhm.
and I'm going to wave it and magically in about 30 minutes, it'll be lunchtime for us. Okay,
Oh.
ready?
Awesome.
Okay.
Thanks, Mr.
Nice.
Kevin.
Oh, and I'm in the green zone.
Okay, well, good. All right, friends, before we get going, let's review our personal standards.
Today and every day, we agree to
Show respect, make good decisions, and solve problems. And one way we show respect is by honoring our indigenous lands and peoples and recognizing the land that we're standing on.
I'm going to invite you to look outside your window, look at the sky, look at the trees, look at your surroundings. Our physical space stands on the historical and ancestral land of the Puyallup tribe of Indians. We acknowledge the Puyallup tribe of Indians community, their elders, both past and present, as well as future generations. We make this acknowledgement as part of our work to dismantle the ongoing legacies of settler colonialism and white supremacy. And as we move forward throughout this year and on with life,
Yep.
Mrs. Wally and Mr. Kevin and I have made that commitment to learn more and think about the lens through which we're looking at things.
Because there's lots of different lenses. It's
Yes.
important to look from various different perspectives before you make decisions
Yes.
and to learn. When you know better, you do better. And there's nothing harmful about learning about someone's culture and their lives and their ancestors.
Mhm.
Nothing wrong with it. And so it's important that we do it so we can understand the people we share this space with.
Mr. Kevin.
Just wanted to give you some perspective. I've been reading about this lately,
Oh, have
recently.
you?
And so, you know, we've been here, the Western settlers, right? Us who came from the east to the west, you know, a few hundred years.
Mm-hmm.
The 1800s in that area, you know, we started to migrate out after Lewis and Clark did their expedition and were helped by the natives, by the way.
They were.
Well, so the natives have been here. They came over the Bering Strait land bridge, some say 20,000 years ago.
Wow.
A long, long time.
Yes.
So this, if you look at it from that perspective, this is very current history for them.
Absolutely. Very current. Very current. And we as humans can't, you know, we can't conceptualize 20,000
It's a long
years.
time ago.
It's a long time.
Yeah.
Yeah.
Wow. Well, thank you.
It's hard for us to see beyond our own lifetimes,
It is.
right?
It is. It's hard to comprehend that.
Harder to comprehend it.
That's
Yeah.
why it's so important to learn, because it's really hard to comprehend unless you really take the active role of learning about it and to understand.
So let's get learning.
Let's get learning.
Not that that wasn't learning, because that was learning.
But
But the focus of this lesson.
yes,
We're going to remind ourselves of the scientific process.
I won't gab about it too much. We've gone over it a lot, but scientific process never ends, friends. There's always more to learn, and it's important that we follow it so that we have reputable and true information.
We start by not start, but part of it is making observations, asking questions, sharing data and ideas, and reading about science discoveries, which is what we're going to do today.
We are. And then we start to come up with explanations and collect data and interpret observations and revise what you thought before based on that information you gather.
Then you can learn more. This might be where you're starting to satisfy or answer some of your questions or curiosity and solve problems.
And this is an important time where you might want to send it over to some of those friends to get feedback. Even any of them. At any point, you can send it to your peers to get feedback. But this is an important part that happens at the very end of research studies, is it's sent to peers to validate it and make sure that you follow the process and that it's as true of information as we know at the time.
And make sure it can be replicated, which means if you're doing an experiment, in order for the data to be valid, it has to be able to be repeated in other settings by other people.
That's right. More than one person has to be able to repeat it. Oh, this is such a good one.
Okay. We're going to look at this phenomenon. And this was a person who was shoveling mulch, which is like dirt and detritus that you put in your garden. And the outside temperature was 64 degrees Fahrenheit. But the inside of the mulch pile was 127 degrees Fahrenheit.
Or 53.3 degrees Celsius, which is what you see there on the thermometer reader.
Where is this heat coming from?
Wow.
What do you think, friends? Something to think about.
We're not going to answer it.
I know where it's coming from, but I'm not going to answer it. See if you can figure it out. Might have to do some research on your own.
Yep. Okay. And this is important because we're thinking about how do different forms of energy influence a region's economy.
Right.
Different forms of energy influence a
economy.
region's economy.
Okay.
I'm just going to take a drink of my coffee.
Now it's time for a stretch while Mr. Kevin gets ready for his and our big science word.
Fifth graders, I hope you have as much fun as we have. So, time to review our big science words.
We learned about an economy, which is how money is used or made in a region.
And energy, which is the power or ability to make something work or be alive. I like energy.
Yes. We ready for our energy sound off?
Yes.
Okay.
We just know because we've been told.
Energy's worth its weight in gold.
People use it every day.
Its sources help us work and play.
Sound off.
Electricity.
Sound off.
Light.
Sound off.
1, 2, 3, 4. Heat and sound.
Chemical energies all around.
Some of it lies underground.
Once we use it, it is gone.
If we don't conserve it, won't be long.
Sound off.
Oil.
Sound off.
Coal.
Sound off.
1, 2, 3, 4. Non-renewable.
Thinking about sometimes it's produced underground. Thinking back to our picture.
Ooh.
Other sources do abound.
We just need to take a look around.
Water, wind, and yes, the sun.
Generate energy by the ton.
Sound off.
Wind turbines.
Sound off.
Hydropower.
Sound off.
1, 2, 3, 4.
Renewable.
And that was by M. Watman Turner.
It's a really good one.
Okay, we started this input chart.
We sure did. And I don't even know we're going to finish it today.
I have a feeling we
I have a
won't.
feeling we aren't.
And we just have to be okay with that.
Yep, we're going to go. It's just like in class.
Wow.
Your teacher expects a chart or something to happen, and you only get halfway through because you had a great time talking about it.
Exactly.
So, Ms. Oslin, tell us what's going on.
Well, we're going to start by reviewing, looking at our chart, which is about forms and transfer of energy.
We had the sun.
We started with the sun, and that was a primary
energy source of heat. And the heat and light come down to things like photocells and solar power and create kinetic energy.
Ooh,
Solar
kinetic
power.
energy.
It also causes wind. When you have warm air and cold air and they're moving towards each other, that's what creates wind. That's what creates wind. And so we have wind power with turbines, and it's kinetic energy. Or the thermal heat coming from the sun can dry your clothes out on a clothesline, another form of heat kinetic energy. And then there's photosynthesis. It's that process that plants use to grow by taking the sun's energy and turning it into nutrients for itself. And then we have another kind of energy that doesn't come from the sun, but it's water. Hydropower. We talked about the difference between potential energy. Remember, that's all the energy you could have
Stored up.
just like your potential. And then kinetic energy is the actual energy that's then produced. Kind of like a lake holding water in a reservoir, and then them letting some water through the turbines. That's the kinetic energy, the water coming and falling out and creating energy in the turbines.
When there is movement,
There is energy.
there is kinetic energy. And remember the potential, like Mrs. Wally gave us that great
I love it.
example, or not example, but a way to remember potential.
It's like you have a lot of potential. You, the world in front of you. You could do many different things. What you choose to do is your kinetic energy. It's the actions you take.
I loved it.
So that's where we are.
That's
and then we
where
had
we
to
are.
stop because we ran out of time.
And you did some thinking about what are different ways that the sun's energy transfers to electric energy. And that's
Right.
kind of where we left off.
It is. So now we're going to talk about the demand.
The demand.
When we pull energy away and use it
Why do we need to store potential energy
in an electric power plant.
and then use it? Okay, in our homes, we use electricity to run machines like stoves and radios, computers, charge my cell phone. We turn on our lamps and lights so that we can see. Electricity is kinetic energy because it involves the flow of electrons along a circuit or jumping electrons like in lightning.
Okay, give me just a second, Miss Oslin. Okay, here's the radio. Someone's sitting in front of a little radio here.
Jumping electrons.
Okay, can you say that again?
Yes. Gotta find my spot. in
The
my
electron
notes.
spot. So I've got our house.
We turn on our lamps and lights so we can see. Electricity is kinetic energy because it involves the flow of electrons along a circuit.
Electric energy. Electrons flow. So they're coming from the electric plant and they're flowing along these lines or circuits. Okay, go ahead.
Okay. Or jumping electrons like in lightning.
Ooh, I don't have that here, but I'm gonna.
Oh, nice.
Because
Yeah.
that was information that caught Mr. Kevin's attention. was
It sure
jumping
did.
Electrons.
Be cool if we could figure out a way to store that potential energy from that. And look what happens.
And it goes into the home, and then we
use it.
Atoms. Because the electrons are moving, electricity is a form of what kind of energy? Kinetic energy, because it's moving. Tiny electrons leave the electric power plant and travel along the lines in a current. The electrons travel along power lines. These lines are dangerous because they are high voltage, so they can travel for so long along the wires, or so far along the wires. These wires go into an electronic transformer to change to a low voltage before it goes into our homes. Electric energy changes into light and heat energy when we turn on a lamp. The light bulb shines bright and also gets hot to the touch, depending on the type of light bulb. that
Right,
you're
we have
using.
new light bulbs that don't get hot.
The LEDs.
LED light bulbs. And they use less energy.
They do.
So it conserves that potential energy so other people can use it.
Another form of kinetic energy is sound energy,
Ooh.
which we can hear with our ears and feel with our touch. Sound happens when objects vibrate. Sound energy comes from motion energy. If two things are struck together like this, sound waves are formed which travel to our ear in waves.
Mm-hmm.
Our throats also vibrate to make sound. So if you put your hand on your throat and make a humming sound, you can feel the vibrations in your throat. That's sound energy. The strings on a guitar vibrate when plucked to create music. A sound we like, just like the sounds we hear with radio and TV and light too. Many machines in our homes make sounds when they operate, which we call noise. I hear a noise right now.
I did.
I hear Mrs. Wally's computer.
I hear cars outside.
Car.
Mm-hmm. I hear my markers preaching on the paper.
Yes. So this is where we're going to pause and do some processing. We did a couple minutes of input. That's teaching you what we want you to know. And now we're going to pause. I'm going to ask some questions. You're going to stop. You're going to think. And you're going to jot any notes down. The question I want you thinking about, and this is a really good one, what type of energy is the most important to you? Is it light, heat, sound, or electric?
Kind of like the question, if you could only have one, which one would you choose?
Mrs. Wally is giving me her signal that she's ready. Go ahead.
Electric,
Why?
because I can produce sound and heat from electric energy and light. If I have just light energy, I can't make all those other things. But with electric energy, I can turn on a light, I can turn on a stove, I can turn on
Here's
a
my
heater.
question. Where are you going to get your electric energy?
From my power plant,
That gets it from
the sun.
the sun. So you have to have your heat and your light to make electricity, to make heat and light.
But if I don't have an electric power plant, then I
Then you can't do anything
transfer
with
it.
that potential energy.
Where I'm just, you have to have it all. But if I had to choose one, like
had
I
to
can
choose
only have
one.
one kind, I
Yep.
would do electric, figure out a way to make the electric energy with some kind of movement. Because I could then take my own thoughts and make some kind of movement that then generated electricity.
I was thinking heat, because I can do without light, I can do without electricity, but without heat from the sun, there will be no life.
True.
But that's thinking of a primary source of energy rather than the secondary source that comes
Right.
after.
And
So,
they didn't say the sun.
They didn't say that.
They just said heat or light. They didn't say the sun was going to be gone. They just said what kind of energy.
Isn't that amazing how we thought of it in two different ways?
I wonder what you're thinking at home. Were you thinking more along the lines that I was? Power lines. Or more along the lines of Mrs. Osmond?
No wrong answer.
I was thinking, the lines from the electric power plant. You're thinking more along the invisible lines from the
Yes.
sun.
Okay, let's do some more learning
think
about
we can.
energy and resources,
Okay.
renewable and non-renewable. Okay, when energy is waiting to make things happen, we call it
Potential
energy or stored energy.
Hmm.
An important form of potential energy is chemical energy.
Ooh, chemical energy.
Chemical energy is found in the bonds, like glue, between molecules or building blocks of all things.
Ooh.
When the bonds are broken during chemical reactions, energy can be released.
Ooh.
Light makes chemical energy as food in plants through photosynthesis.
Hmm.
People and animals then burn the plant's food during digestion so they have energy to live. You have energy to play because of the chemical energy in food.
Like if you're playing soccer.
Yep.
We were talking about beginning of this that we were going to eat food and turn it into energy, chemical energy.
More of the world's chemical energy comes from the sun in another way because it was made from the fossils of dead plants and animals millions of years ago. These fossils became fossil fuels, which are stored inside the earth as potential energy or stored energy.
As carbon.
Coal.
Hang on just a second. I was trying to figure out where we were on our chart, and I'm there now. So this is animal and plant fossils. Okay.
Coal is a solid fossil fuel that is mined or taken out of the earth and used to burn to heat our homes and make electricity.
Go to the electric plant. We'll do that at the end on the way up. Okay.
Natural gas is a fossil fuel that is a colorless gas like air, and we burn in our furnaces, stoves, and dryers to create heat.
Yep, my dryer is. Okay. All of these things are the potential energy. Okay.
Oil is a liquid fossil fuel that we drill out of the earth and use to create petroleum, gasoline, diesel, and oil. We burn these fuels in our homes for heat or to make our cars and trucks run.
Okay.
Another form of chemical energy is the radioactive mineral from the earth called uranium. It can release the energy when the bonds in the uranium break. This energy can be used to create electric energy in a nuclear power plant. All of these fossil fuels can be burned in an electric power plant to create electricity. Unfortunately, pollution that causes global warming is produced when we burn fossil fuels, and dangerous radioactive material is left over from a nuclear reaction.
These are all non-renewable.
Because these fuels took so long to create, they are limited or will run out. It would take too long for the earth to create more fossil fuels for people to use for all their wants and needs. We call fossil fuels non-renewable resources because the supply is limited.
Now I'm in this internal battle as I'm doing this chart over here around the plant photosynthesis, because I think it could be renewable or non-renewable because we're going to use it. But if I think about it in that way, it doesn't take the earth very long to reproduce plants. However, if we use all of them and aren't careful to make sure that we continue the breeding of the plants, we will run out.
Which maybe is what happened with our fossil fuels.
Right. And so those plants are kind of in this like in between, which is they're kind of in between here, like this kind of a greeny blue area.
It's all about.
This is not greeny blue. This is like it can happen forever, right? But this here is like, well, if we're not careful, now it doesn't create the issues that these do with the fossil fuels. It's cleaner energy. I don't know.
Okay, now
So here's something to think about that's kind of interesting. I think that our fossil fuels that we have, like the oil and the gas and all that stuff that's underneath, all of that was created by plant material that had died and got compressed over millions of years. Isn't that wild to think about?
It is.
It is. And the more I'm thinking about it, this goes up to the renewable plants. So I think I'm going to do all of this green.
Okay.
If you're okay with that.
I'm okay with
that.
that.
But it is chemical blue here, just so we remember that it's chemical potential.
Okay, now we're going to talk about car and gas stations.
Ooh, yes.
When the supply of fossil fuels go down, that means when we start to run out of what we have, and the demand, which is how much we want it or need it for fuel, is high, the prices go up, which is what is happening today with the price of our gasoline. The United States gets the majority of its oil from other countries around the world.
And I'm going to do this gas station because the gas station is the demand.
This is where we're talking about our economy, right? How we use or spend our money. So if, as a country, we are using money to purchase oil and other fossil fuels from other countries, That's money that's going elsewhere.
But if we start to use other resources, what's going to happen to those resources? It's a thought I've had. You have to get the energy from somewhere.
Right.
And if you're going to be burning coal to get electric energy to then put in your car, that's just as bad as using the oil.
Other sources of energy can be used again and again to create electricity or make fuels. So we call these renewable or in an unlimited supply. Light, wind, solar, and hydropower are examples because we'll always have light, wind, solar, and water.
We hope.
We hope. Another form of renewable energy is to use the heat inside the earth, like steam and geysers. This is called geothermal energy.
I'm wondering in my head right now, I know that Yellowstone National Park has a lot of geysers, and I'm wondering if they're using any of those or if they've decided not to use those to protect. I don't know.
That's a good question.
This I don't know.
Plants can be used as biomass.
Oh, I meant to do that green. Mrs. Wally. Sorry, friends.
That's okay.
Luckily, I'll just make it green. If you give me just a second. Thank you, Miss Oslin. We hope it doesn't run out. We don't think it will, but maybe
And it's
one day
green
it will.
because everything green is a renewable resource. Renewable energy that...
I just had the wrong pen in my hand.
It's okay.
It's a very complicated chart, friends, which should tell you how complicated this is. Okay,
Right?
where are we at?
Okay.
Biomass?
Plants, biomass, to create electricity and make chemical fuels to run our cars. Some examples are corn, wood, sugarcane, garbage, and vegetable oil.
Well, if we burned the garbage, we could stop the issues with our garbage pollution issues, but I don't know how great that is for the ozone and, you know.
Right? A renewable fuel plant uses biomass to create ethanol, biodiesel.
Okay, here's our plant. Choo. Okay.
What we could also do is take water molecules and split them into the hydrogen and the oxygen, and we can use the hydrogen fuel as
But
energy.
then we get rid of water.
Oh,
See? It's all an issue. We're going to be using something up, so we better be careful.
so the important thing for us to remember that Mrs. Wally is pointing out is that all sources of energy have their benefits and their drawbacks. Chemical energy can also be burned like wood in a fireplace to get heat energy.
Oh, I think we did it, Miss.
Wow. Now again, you've had a lot of input. This is the question that we want you thinking about for your processing is, what is one type of renewable source of energy?
And maybe even further, which one do you think we should use the most, or should we spread it out? And why?
Yes. Mr. Kevin has an answer already.
Well, actually, I have a question.
Hey, questions are great.
Did you talk about thermal energy?
Yeah, heat.
Yep, geothermal.
Heat. Geothermal.
Geothermal.
Okay,
Yep.
good.
We did.
Good. Okay.
Wow, lots of information. We're going to continue thinking about how do different forms of energy influence a region's economy.
So this is just the start. You had to learn about all the energy and how we use it before we can learn how it influences anything. We're going to be doing more talking about it.
You're going to do some thinking about what you think you know about energy, what you want to know about energy. And you can post on Flipgrid. What are some things you're wondering after learning about how this infrastructure works together? Now, if you're not comfortable posting on Flipgrid, that's okay. There are 2 other ways that Mr. Kevin's going to tell you all about how you can get us the information.
And I'm going to take a picture of this so I can put it on Flipgrid.
Yeah, cool. And while you're doing that, I'm going to say, 5th graders, if you can find the energy, send us an email to tvclassroom@tacoma.k12.wa.us, or why don't you mail something to TV Classroom, our beautiful downtown Tacoma headquarters at 601 South 8th Street, Tacoma, Washington, 98405.
Awesome. Mr. Kevin. We did it. We did that whole thing in one lesson.
We did.
Nice.
Really well, actually.
Yes, I agree.
Nice job, Miss Oslin.
Nice job, Mrs. Wally. Thanks. Teamwork.
That was a lot of information, guys.
It was great. We're going to be using it a lot. So don't worry if you're like, whoa, information overload. We're going to be going into each of these separate things and going into great detail. This is what we call the 30,000-foot view.
Yes.
Big overview.
Yes.
Now we're going to zoom in on different types of energy to learn how they impact our economy. But you needed the big overview to understand how connected and complicated it is.
Yes, because it is. Hey,
That it is.
I think we need to remind ourselves that we are responsible users of energy, because we're starting to talk about renewable and non-renewable resources, and that all of these forms of energy have their benefits and their drawbacks. And we as humans and consumers of energy need to be really aware of where our energy comes from, how we're using it, and what are the implications.
And you are fortunate that you are living in a time where we are in real life having this push and pull happening right now in our country around our economy. And people are kind of on either end of the ideas and have their valid reasons. And so you're living in a time where you may get to see a really big change happen in your lifetime around energy, which is really cool.
Very exciting. You could even be a part of the change.
Absolutely.
Right? Let's take a deep breath together.
Can you tell me what it was again? I'm sorry, I forgot.
I am a responsible consumer of energy.
Let's do it.
I am a responsible consumer of energy. Excellent job today, 5th graders. We hope you have a great rest of your day. We look forward to seeing you back here next time in our TV classroom.
See you on Flipgrid.
Rules. 1. You have 10 seconds to pick your crewmate. 2. A new timer will appear with an exercise for the crewmate you picked. 3. You will get 10 points for each correct crewmate and exercise you choose. 4. If you pick the imposter, you will lose all your points. 5. See how many points you can get. Good luck.